Okay, good morning everybody. We're going to finish up our notes on the mole. So go ahead and take out your worksheet. And yesterday we started with this, mole notes part 1. We're going to go ahead and do mole notes part 2 today. Okay, so the first thing we're going to talk about is the difference between an atom and a mole. So if we look at the atom, it's an individual atom of aluminum. We look it up on the periodic table. We see that it's got a mass of about 27. Okay, we know that it's got 13 protons because that's its atomic number. And so if we add up protons and neutrons, we're going to get a mass of 27. So if we have this single atom of aluminum, its mass is going to be 27, and that's equal to protons plus neutrons. So what chemists have done, and this is really nice, is we have come up with a way to quantify a large amount of those atoms so we can actually measure them in a laboratory. And yesterday we talked about the mole, and so what we've done is we've said, okay, we're going to put a number on the periodic table that is equal to 1 mole of that substance. So if we were to take 1 mole of aluminum atoms, it's going to weigh 27 grams. So if we have this block of aluminum, let's say, okay, we have this block of aluminum, and we're saying it's 1 mole, it's going to weigh exactly 27.0 grams. Okay, same thing with calcium. Calcium's a little bit bigger. So the atom itself, if we look it up on the periodic table, calcium's got 20 protons, that's its atomic number. It's also got 20 neutrons, so that gives each atom a mass of 40 atomic mass units, which is protons plus neutrons. Okay, but a single calcium atom, there's no way to measure that in the laboratory. So if we take a collection of those, if we take, to be specific, 6.02 times 10 to the 23rd of those, we're going to get an even bigger sample than the aluminum because these atoms are bigger than aluminum atoms. So a mole sample of calcium, all right, is going to be a lot bigger. And if we take 1 mole of that, we're going to get 40 grams. Okay. So everybody's going to need their periodic table for this next part. And so make sure you've got that out. And we'll do these practice problems together. So number 3 says, what is the mass in grams of 2.38 moles of zinc metal? So just like the problems we were doing yesterday, we're going to start by writing what we know. So 2.38 moles of zinc metal. Okay, then we're going to take our units, which are moles of zinc, and move those down and to the right, just like we were doing with our problems on the front. The question is asking for mass this time. Yesterday, if you'll remember, we were asking for atoms or moles. Now we want to talk about mass in grams because that's a lot easier for us to measure in the lab. So the number of grams of zinc is what's going to go on top. Now we've got a conversion factor for every single element, and each one is going to be different. Our conversion factor is going to always be 1 mole is equal to a certain number of grams. And the way we figure out that number of grams is by looking on the periodic table. So the one we're looking at today is zinc. So let's find zinc on here. Here it is. Okay, you'll notice this is a decimal number, and we're going to round to the nearest whole number for these when we take it off the periodic table. So this is 65.39. We're just going to round that to 65. Okay, so if we were to take 1 mole of zinc it's going to weigh exactly 65 grams. And remember that 1 mole is 6.02 times 10 to the 23rd particles. So if we have that many particles of zinc, it's going to weigh 65 grams. All right, so I've already got my units set up, so let's plug in my numbers. 65 goes on the top, 1 mole goes on the bottom. So we're going to multiply across the top 2.38 times 65, and then we'll divide that by 1. And we should come up with 154.7. If we type that in, I'm going to go ahead and round that to 155 grams of zinc. Okay, now we can also go the other way. So if I were to take a sample of lead, for example, like 285 grams of lead, and if I wanted to maybe know how many moles that was, we could do that easily as well. So we'll set up our little grid here. We're going to take our grams of lead, move that down and to the right. Okay, and we're going to use the same conversion factor. So 1 mole of lead is going to be equal to however many grams of lead we see on the periodic table. So again, we'll take this out, we'll find lead. Here it is, it's number 82. And the mass number here is 207.2. So that means for every 1 mole of lead, there's 207 grams of lead. Okay, so now we can plug this in on the bottom, 207 grams. The question is asking us for moles, so we want moles on the top. Okay, 1 mole is equal to 207 grams. So this time, we're going to take 285, multiply that by 1, which is just 285, and then divide that by 207. And we should get an answer of 1.38 moles of lead. Okay, now on your mole worksheet 1, which looks like this. You guys yesterday did problems 1 and 2 and we checked those. We're going to go ahead and have you do questions 3 and 4. And they look very similar to the ones we just did, questions 3 and 4 on Mole Notes Part 2. So go ahead and use your notes to answer questions 3 and 4.